So I noticed that this on page 2 is not highlighted, but I noticed that in other parts of the notes, things like this are highlighted. So the way to read this is this superscript in the upper left-hand corner is what's known as the mass number, and this capital letter here represents an element. So in this case, capital C represents carbon. So this would be carbon 13. And then down here, this would be carbon 14. So you could say the carbon 14 isotope, and here's its symbol, would have 8 neutrons. All right, let's see where we are. Okay, so here we are on page 3. This has been highlighted, and I've also added some prompts in here. So Fe3 plus, Fe plus 3, or iron 3, or Cu2 plus, Cu plus 2, or copper 2. We haven't gone over naming yet, so I think it's okay just to refer to these in terms of the letters. Down here, N3 minus, or nitride, and Cl minus, or chloride. And then down here, Na plus, or sodium, O2 minus, or oxide, and then down here, CO32 minus, or carbonate. So I just want to interject right here that we will go over how to name these. So right now I think it's okay just to indicate the letters, the numbers, and then afterwards say the actual name. There are 4 atoms in this ion, 1 carbon atom and 3 oxygen atoms with an overall charge of -2. And NH4 plus 1, or ammonium. There are 5 atoms in this ion, 1 nitrogen atom and 4 hydrogen atoms with an overall charge of +1. I'll put a parentheses there. Okay. So down here, Na plus, or sodium plus, likewise S2 minus, or sulfide, 31P, or as a name such as phosphorus 31. Okay, so down here, I think it'll be important to actually name these as the isotopes that they are. So this symbol would be read 63 Cu plus 2, but at this point, since I've already explained how to write this, I think we should specifically refer to this symbol as the isotope with its correct name. So we would call this copper 63 with a +2 charge. And then here, the symbol aluminum 27 with a +3 charge. And then down here, tellurium 128 with a -2 charge. Okay, then of course AMU stands for atomic mass unit. That's already been addressed in the notes. I already told them what that meant. And again, AMU, atomic mass unit. So I'm not sure if you need to say atomic mass unit every single time. They already have been told what that stands for. It's perfectly acceptable to say 63 AMU, and the students should know that that means atomic mass unit. So you can just say AMU and not atomic mass unit. Again, here you have in blue this atomic mass unit. I don't think it's necessary to say atomic mass unit. You just have to say AMU. So here, again, we're looking at how the element symbols have actual names. So capital L, lowercase I is lithium, capital N, lowercase a is sodium, capital K is potassium, capital R, lowercase b is rubidium, capital C, lowercase s is cesium, and capital R, lowercase f is francium. And so here we can say the salt contains the sodium cation, Na+, and then down here the diatomic elemental molecules are sometimes known as the super 7. That's typo. Molecules, sometimes known as the super 7, let's put that in parentheses, are capital B, lowercase r, subscript 2, bromine, capital I, subscript 2, iodine, capital N, subscript 2, nitrogen, capital C, lowercase l, subscript 2, chlorine, capital H, subscript 2, hydrogen, capital O, subscript 2, oxygen, capital F, subscript 2, fluorine. And sulfur exists as capital S, subscript 8, and phosphorus is capital P, subscript 4. It can get kind of tedious to mention when it's capital versus lowercase, and since the students will be viewing this, You could just say BR2. That's what I would do in the class. Or, if you feel like you really need to, for clarity, specify that it's capital, it should be capital. I just get lazy during class and let students see for themselves that it's capital versus lowercase. But it makes a big difference. But I've also already addressed that in the notes as well. Okay, so here we have such as Na positive sodium, Ca plus 2, or calcium. Just put that, or calcium. Aluminum has a plus 3 charge, Al plus 3. Zinc has a plus 2 charge, Zn plus 2. Silver always has a plus 1 charge, Ag plus. Metal cations, for example, Na plus is the sodium cation. So I guess one of the challenges as you're reading this is how do you refer to these, and I think it's okay just to read out the letters, and then as students go through the class, as they get more familiar with it, of course a chemist would never call this Na plus, we would call it sodium cation or the sodium ion. And same thing down here, we would call these the copper plus 1 cation, the copper plus 2 cation. But as we're introducing it, you can just call it Cu plus and Cu plus 2, although it kind of makes me cringe. So let me just say here copper 1 and copper 2 respectively. Okay. So here I've added in parentheses what these are called. I mean, I say that at the end. So I don't know. I just know how a chemist would talk about this. So I'm just going to talk about it as a chemist would talk about. And for example, copper 2 has two common ions, Cu plus 1 and Cu plus 2, copper 1 and copper 2 respectively. Although the number of protons is the same in each cation, they are very different from each other chemically and physically. Copper plus 2, copper 2, tends to be a characteristic turquoise blue, while copper 1 is dully colored. Because copper plus 1 and copper plus 2, copper 1 and copper 2 are different chemicals, they need different names. The name of a metal cation with a variable charge is the elemental name with the charge indicated by a Roman numeral. Thus, copper plus 1 is copper 1 and copper plus 2 is copper 2. I guess I should put these other Roman numerals in parentheses. So here again, we're going over the names, so I think that we just want to mention the letters and the overall charge because we're going to learn how to name these down here. So the halogen family forms anions with a -1 charge, such as Cl-. The nonmetals in the oxygen atoms form anions with a charge of -2, such as O2-. Nitrogen and phosphorus can form anions with a -3 charge, but these tend to be unstable. The name of these anions is the elemental root name and a suffix of "-ide". Thus Cl- is chloride and O2- is oxide. Charges of the anions is not variable. Two common polyatomic ions that do not have the suffix are cyanide, Cn-, and hydroxide, OH-. Most of the polyatomic ions used in Chem 151 are anions. Okay, so here I really don't want you to put the names here. I mean, because the whole point of this is for them to figure out what the names might be and what the charges is. So I really don't want you saying potassium or calcium or ammonium, especially with that plus sign in it, because that's the whole point of it. They've got to figure out what the charge is. And fluorine is going to be a different name than the anion, and sulfur is going to be a different name than the anion. So I really want you to take this out. I don't want you to include that. That kind of destroys the whole purpose of the exercise. What you can do instead is you can just say what the letters are. So, for example, for K, just say K. And calcium, just say capital C, lowercase a, and NH4, and F, and S, and CO3, and PO4. I do not want you telling them or indicating what the charge would be as you do here, because that would be giving away the answer. And the answer key is right down here. They can look at that if they need to. But if you give them the answer to begin with, then there's no point in doing the exercise. So please make sure that you get rid of all of this, or else it's going to be completely useless. So here, compound NaCl, sodium chloride, contains one Na plus or sodium cation for each Cl minus or chloride. So I've already explained how to name these, so we really actually should not be having the Cl minus. We should actually be calling them by the names, because I've already explained how to name them. So trillions of sodium cations and chloride anions, even in the smallest crystal of NaCl or sodium chloride or table salt. Okay, and again, I really don't want you putting the names here. They're just trying to determine whether the compound is ionic or molecular based on the formula. So, I mean, it's okay, I guess, if you put the name, that's all right. But I guess the name is okay. So the names are correctly written down here. So that's okay. The name won't take away from. Okay. So I think that's it. I think that's all that I see highlighted. And hopefully that will help you with the narration of this module.